Assalamualaikum and a very good day. My name is Muhammad Farid bin Suhaimi. I'm going to talk about my final year project 1, which is improvement of design for rainwater harvesting water storage system. Before I go through the main point of this presentation, I will explain the summary of this project. Firstly, there are some problems for rainwater harvesting current design. So this project implemented to improve the rainwater harvesting system in terms of safety and water flow efficiency. Secondly, to improve safety, the height of the tank holding stands needs to be closer to the ground without reducing the efficiency of water flow. Lastly, the parameters obtained can be analyzed by visualizing and simulating the system using SolidWorks software. The presentation will be covered on literature review rainwater tank stand, problem statement and objectives, comparison between three existing designs using per chart, analysis of the problem on current water flow efficiency and stress of rainwater tank stand, and lastly the expected result. For introduction, first we should know what is rainwater harvesting and how significant the system to community. Rainwater harvesting may be the most environmentally friendly alternative for incorporating into the urban water management system. For instance, during the dry season, certain areas have encountered water shortages. As a result, the rainwater harvesting systems allows us to store rainwater for later use. Apart from that, the rainwater harvesting system is the most conventional and sustainable approach, and it may be used in residential and commercial structures for both potable and non-potable applications. In short, a rainwater harvesting system is a device that collects rainwater and stores it rather than allowing it to flow away. Rainwater is collected and routed to rainwater shortage tank from a roof or a slope surface through a rain gutter. The Sustainable Development Goal (SDGs) are a universal plan for all countries to end poverty. There are 17 goals introduced by the SDG, and the rainwater harvesting system is fulfill one of the goals, which is Goal 7, affordable and clean energy. This is because there is no electricity used in this rainwater harvesting system. Then, the rainwater harvesting system also uses gravity as a neutral force to deliver the rainwater to domestic use. The literature review. This method is needed to identify what research has already been done for rainwater harvesting. These are 3 out of 10 journal articles that have been reviewed. First, Engel stated that due to the rapid urbanization, the rainwater harvesting system have potential to assist cities to increase local water shortages. Second, Sha'ari also mentioned that there are different types of rainwater utilization. First, conventional, and second, integrated rainwater harvesting. Thirdly, Krishna Reddy and Channababu also stated that the research focused on how elevated rainfalls concrete water tanks function under dynamic loads, including the influence of sloshing. Next, for the problem statement. This statement is significant in determining which parameter in this project should be improved. First, the excessive height of the rainwater tank stand. Hence, the excessive height can cause hard to do maintenance and also low stability. Next, the current design also have unbalanced distribution load for the rainwater tank. These are objectives and scope and limitation of the project. For objectives, first, to reduce the center of gravity of the rainwater harvesting tanks to ensure safety and ease of maintenance. Second, to recommend the best height for the stand in rainwater harvesting system without compromising the water flow efficiency. For scope and limitation of the project's outcome can only be obtained through simulation. Second, SolidWorks software is utilized for simulation, which may not be as realistic as the real-world condition. And last, data collected throughout 10 weeks observation during internship. For methodology, I construct a per chart to decide which is the optimum design for a rainwater storage stand. This method is used to compare the new design to other water storage stand designs currently available on the market. Based on the per chart overall weighted score, the selected design is design 1 for the stand dimension. The height is 3.08 meter, the width is 1.56 meter, and the length is 9.02 meter. Then, after the modeling process in SolidWorks, stress analysis has been conducted to evaluate the design's material failure. Before do the analysis, the material and value of the total force need to be identified. The material of the stand is galvanized steel. The weight for each tank with full capacity of water is 1.5 ton. So, the total weight force for 4 water tank on the stand is 62.392 kN. And the process of material selection will be much easier with this method. If the surface part is completely blue, indicates that the material employed can take the weight of the water tank. Next, for the flow analysis, this analysis is important to identify the characteristics and efficiency of the flow. As we can see here, this is the current parameter for the pipe that delivers the rainwater from the tank by only using gravity force at a particular height. The diameter is 48.26 mm and the material is PVC rigid. And this table shows the analysis result for 3 meter per second water flow. In conclusion, we know that in urban areas, rainwater harvesting systems are extensively used, so the safety of the rainwater storage is important to the users, and choosing the proper height for water tank stand and material is critical for achieving maximum safety. And the size of delivery pipe should be carefully selected to ensure consistent water flow performance, since it has a significant impact. For the expected result of this project, the stand can support the full rainwater tank without any damage as the stress analysis result. The material used for the stand, which is galvanized steel, can prevent rust and corrosion to enhance the life cycle of the stand. And the water performance will be increased by utilizing small pipe diameter as the flow analysis which has been made. For my future planning for this final year project is I will redesign the system with new parameters, such as reduce the current storage stand height and change the size of delivery pipe and reanalyze the flow performance using flow simulation. Apart from that, the cost for fabrication will be considered to complete this project. Then I will discuss with co-supervisor to obtain cost information and compare the cost for stand materials. Okay, these are journal articles that I chose as references in my literature review. As we can see here, this is my Gantt chart throughout 14 weeks for final year project 1. The brown color represents actual progress, while the peach color represents planning. This Gantt chart consists of all my activities and their timeline. And here is the Gantt chart for final year project 2 planning activities. If there are questions that related to my project, you can contact me through this number and email for further information. And thank you for paying attention.